Okay, welcome to a video on using a calculator to just do some basic addition and subtractions, and this is really a practice on using this curve, understanding the normal curve, which will come up in statistics portion of this class. So this says use the percentages in the figure below to estimate the total percentage under the curve between the indicated values. And it says find the total percentage between 74 and 86. So here's the 74 mark, and here's the 86 mark. And what's notable is this is referred to as the normal curve. And the center value is the mean, which I'm sure you've heard of. It's like the average. And the scale is called the standard deviation, which you will become familiar with as you move into the statistics section of the course. And it says the percentages given are only approximations of the portions of the areas under the normal curve. So basically what this is saying is this 34% indicates that between 74 and 78, if those were like scores on test scores, for example, 34% of the scores would be from 74 to 78. And 13.5% of the scores would be from 78 to 82. You've probably heard of grading on a curve before, and this is what that would indicate, something like that. If an average on a test was 74, and the standard deviation, which tells you kind of how the scores would be spread out, how they're spread, if the average standard deviation were 4, then back in the old days when they used to grade on the curve, it's not done much anymore, about from 70 to 78 would have been about 68% of the students would have gotten scores in that range. From 78 to 82, scores in that range, 13.5% of the students would have gotten a B. And then the top 2.35 would get an A. 0.15%, that's less than, that's less than 1 in every 100. That's like 15 in every 10,000. So that's very few would get that score. And then below 60 to 70, that would be the D range, and then anywhere 66 and below would be failing. So just so you might ask, what percentage of the students would get between a 74 and an 86? Well, it's pretty straightforward. 34%, 13.5%, and 2.35%. So I'll just put those in. 34. Now, I don't need to put a percent sign because these are all percents already. 34 plus 13.5. That gives me the 78 to 82. And then all the way up to 86 is going to be plus the 2.35. And it's that simple. It's really not much to it. And that's 49.85%. What I want to point out is there's actually a quicker way to do that. On a normal distribution, on a normal curve, you can see we can, from here to the right, all of this, that is 50% of all the data would get from the average up if it was called a normally distributed. So that's 50%. So we could have more easily taken, if from 30, this half, if this is half of them, or 50%, we could have just subtracted, right? If 74 over was half of them, we could have just taken 50 and gone minus 0.15, and that would have been a quicker method. It still gives us 49.85, but it's a little faster. Okay, I hope you found this video helpful.